Hi, welcome back. Today let's talk about logistic regression using KNIME. So as usual, first we will pull in our data source and see what kind of problem we are going to solve today with logistic regression. So I have my CVS reader and then I will point it to the data source that we have at hand. And just to remind, any kind of logistic regression or classification problem deals with the classification of identifying the categorical variable. Okay, so here we have configured our data source and then let us execute. And now we have our table with 768 rows and 9 columns. As we look at the columns, we infer that all the data type. Now this is a data set of a set of patients who are diagnosed with diabetes, which is represented with a class variable and this is based on the diagnostic parameters that are diagnostic features that are captured in the table. In problem or in any kind of logistic regression or classification algorithms, the outcome is always to identify the predict the categorical variable. So here we have a class variable with values of 0 and 1, which will identify that whether the patient is diabetic or not based on the diagnostic features provided as per the data set. Okay, so now let us see at high level what the data snapshot looking like with help of a data explorer and see what can be done before as part of data pre-processing before we move on to the logistic regression. So to do the data analysis exploration, we will use the data explorer and I will connect the data source and execute and then see how the data is looking like. Now, as we see, all the data, all the columns are numerical in nature. There are no nominal or categorical variables. And as we also see, there are many missing values in most of the variables. Okay, so we need some kind of missing data treatment. And also, as you see here, the class, which is categorical in nature because we are going to predict the probability of a patient becoming diabetic or not, which is captured as 0 and 1, is represented as a numerical variable. But the outcome of any logistic regression is going to be a categorical category, right? So it is best to transform this variable from a integer to a string. So this is done using the CVS reader itself. When we go back to the configure, now we have a transformation tab where we can see all the columns and then their data types. So here it is represented as number and then we want to convert this into a string because we are dealing with a classification problem and yeah, and any kind of logistic and classification algorithms deal with categorical variables. So now we apply this and execute. This time again we will have to execute because the data source has changed. Now you see the class variable has turned into string from integer. As you also see from the view, earlier all the variables were numeric, but now we have a categorical variable called class which has two values, 0 and 1, and you also see the distribution here. Okay, so now this is how, and we also saw that there are many missing values, so we will have to do the missing value treatment. So for that, I will pull in the missing values node. Let's configure this node before, and as we see, the number we will, as we have seen in the data exploratory analysis video, for all the numerical and numerical variables, we will treat the missing values with the mean. So that will take the mean as you have seen here in the output view. It will replace all the missing values of these variables with the corresponding mean. Okay, so whatever we have here, it will be replaced. And now we will execute this to validate that we don't have missing values. Let us once again pull in the data explorer and see how does this pan out. As you see now, the missing values have gone now because we have done a missing value treatment. Okay, now the data is ready. We have done the basic data pre-processing, converted the numerical value into categorical variable because this is logistic regression, and done the missing values replacement. Now let's straight away get into the modeling for logistic regression. So as earlier, anytime we have a data set that has to be split into a 70-30 partition for the training and test data to evaluate and to train our model. So let's pull in the data partition node. We have let us configure. We have the default configuration of 30 that we will use it for now, and we will execute. So the table is partitioned into a first partition, which is with 537 records, and the second partition with the 231 records. Now let us pull in the logistic learner, logistic regression learner, connect our training data and configure the node. And how do we configure? This is our target variable, which is the class that will predict the possibility of patient becoming diabetic based on the clinical parameters that we have in the table. And the solver, this is a better solver that will help in the conversion, the sigmoid curve. And we are going to use all the clinical parameters, so we will include all of them and do nothing more, and then just apply and execute this. Now once we execute this, we see that it has calculated the coefficients. Now let us see with help of a logistic regression predictor how this learning is done. So I will say connect the source back from the learner, and to test the prediction of this learning, the logistic regression model, let us use the test data as a source to calculate the predictions, analyze the predictions, and then we have a new predict column. Now this class category is predicted now. This is what is being represented, and also not only the class, we also want to have the probabilities for each of the classification. So that is why we want to append this prediction probability column as well. We will apply and execute. Now if you look at the table here, now this is our actual targeted prediction variable class. Now it has created one more prediction class variable which has actually predicted on the training data, and also it has appended two more columns of the probability of the prediction. Okay, so for anything beyond zero point 0.5 is categorized as positive prediction of 1, and anything less than zero point 0.5 is predicted as a 0. So now this is how the logistic regression is predicted. But now we have the actual values, we have the predicted values. But now the point is how accurate is this model, and then how good is the machine has learned the based on the training that is given. To look at the evaluation of this logistic regression model, let us look at the uh, accuracy metrics, evaluation metrics to see the accuracy of this model. For that, I will use the scorer to see how good the model has been trained, and it can predict the future data prediction of any patient becoming diabetic or not. As usual, let us see the configuration. Our actual prediction value is class, and the second column that we want to compare is evaluate this model on is the prediction class variable. So let's apply and execute. Now what we see is the matrix. So now this confusion matrix is a 2 by 2 way of representing data, like with respect to true positives, true negatives, false positives, and false negatives. Now in this category, the true positives, like the people who have been identified with diabetes at like 46, and then the prediction where the patient will not be diagnosed as diabetic is 128. But then now we have to consider what is this 29, the false negatives and the false positives. Now this will help us to understand the accuracy of model. Now you see it is also calculating the accuracy of this model as 75% 3. How the rest of the parameters are looking like. Okay, now if we look at the accuracy statistics, apart from the true positives, false positives, true negatives, and false negatives, and the accuracy that what we have seen, we also need to consider the sensitivity, precision, and recall, which is talking about the false positives and the false negatives. And to balance out this, we also have the F1 score. So all these things are important for a logistic regression to ensure that our model is like performing well. So with help of Scorer, we are able to see the confusion matrix, which is giving us the true positives, false negatives, and false positives. So and the other rest of the statistics are also important. Here you see that accuracy is 75%. The higher the accuracy, the better the model is. Along with accuracy, we also need to consider the positive prediction in terms of recall, precision, and F1 score. This will this the higher them or the higher this metrics, the better the model is. Now, if we want to look at this is a numerical way of looking at the accuracy of the model. If we want to graphically, visually look at the performance of this model, we have an ROC curve that we can use to. Similarly, we pass on the prediction results to the ROC curve, configure that with the class, so the probability class that we want. We want to exclude this, we want to include this. We want to draw a ROC curve for the target class with the probability of 1, where the prediction of the patient being diabetic is being uh, uh, calculated or classified. Okay, then when we say apply and execute, we see, let's see how the curve looks like. So the area under the curve is telling us that this model is pretty good because this is how a good ROC curve looks like. With the, so this is how we do logistic regression using KNIME. To summarize, we have taken a CVS reader to read our data, have done some basic data pre-processing with respect to the transformation of numerical values into categorical variables, because this is logistic regression, and then we focus on classification, unlike the regression where we focus on the numerical data. So we have done the missing value treatment, and then we came back to the model where we partition the data into 70-30 segments, and then pass the training data for the logistic regression learner, and then to evaluate the model that has been trained, we use the training data with help of the logistic predictor, and then to evaluate the metrics or performance of the model, we have used the scorer to look at the logistic regression accuracy metrics, performance metrics. This visually also can be seen with the help of an ROC curve. So this is how we do logistic regression. Thank you for watching.